Hello, Chelsea. Can you hear me? Share your screen.
Mm-hmm. Mm-hmm.
Okay, so let's do this now, Chelsea. Let's say this is your house here, the wall of your house. Okay,
Okay.
right, Chelsea,
Okay.
and you've got a fence that is of length 10 meters, say. So you're trying to build a small farm, if you like, to look after your chickens. Um, what you got to maximize the area. So the total amount of fencing that you have, 10 meters. Can you see that?
Mm-hmm.
The dimensions of this rectangle or square, that would give us the biggest area. So how do you find out? Basically, I want to know this length and this length in such a way that it will give me the biggest area. And bearing in mind that you have a total length of 10 meters for your fence.
Oh.
Chelsea,
Yes.
how do you do this? How do you go about finding this out? Do you understand the situation?
Yeah. Can you repeat it though?
So you've got a length of 10 meters of fencing. You can build you can build your little farm like this if you want to. You see that? But the total length must be 10. Or you can build it like this. Make it really thin, but make it really long, like this. Can you see that? You've got to maximize the area so that your chickens can walk around. So which dimension will give us the biggest area? Do you understand?
I guess.
So how do you do this? So do you want to make it long and thin like this, or do you want to make it really wide like this? So basically, tell me the length and the width that would give us the biggest area. We're trying to maximize the area with all the condition that the length is 10 meters. How do we do it? What do we need to do, Chelsea?
What? Just make
Do you
it
understand?
10. Like I don't know.
Well, make the length 10. So you're going to build your fence like this, are you? Of 10, length 10. Is that
Man,
how
I
you're going
don't
to build it?
know. But I just. It's a weird question. I don't know how to. Like, how do you even solve
Well,
when asking
weird.
that question?
Why is it weird? Because suppose you're building, suppose you want to build some sort of
Question
pen.
is, how do you find the biggest area using
Yeah.
10?
All right.
Like, how
Just
do you?
imagine. All right. Just imagine your dad bought some fence of length 10. How would you would randomly build it like this, wouldn't you? Randomly, wouldn't you?
Yeah.
Right? Yeah. So all right, let's have a first question of are you gonna make it thin and long or make it high and not so wide? Which one, roughly?
Thin.
Which one using your gut instinct, which one would give you the biggest area? Because you're trying to maximize the area that your
Thin and
chickens
long.
sorry, thin and long. Yeah. All right. All right, let's make this to be one to be one. Is that okay, Chelsea? The height of one.
Okay.
All right. If the height is of one, then what's the length?
10.
What's this length? Sorry,
10. 10.
sorry, 10. Okay, yeah.
Mm-hmm.
But you're told that you've got a total length of 10 meters, and then you've already used 12 meters,
Oh, 5.
5. So this length here is 5. Okay,
Wait, no, no. 8.
yeah, 8. Okay, so basically, oh sorry, 8. So basically build a function or a machine that when I input a length of 8, then you can tell me the area. That's what I want. You got to build a formula that when I feed in a length of 8, then you can tell me the area. Or we can build it so that we can build it like this, Chelsea. We can build it like this. So let's make this 6. Okay, Chelsea.
Okay.
So this is of length 6. What must this be, Chelsea? The height. What must the height be? Sorry?
4.
4. Then this must be 4 as well, right?
Okay.
So what's your length? You've got a length of 14.
2, I mean.
Sorry? Yeah,
2.
2. Okay, 2. Okay, when I input a length of 6 into the machine, what area will it spit out? What's the area of this 10? Sorry?
10. Or 12.
Yeah, 12. It will spit out an area of 12. If I put in an 8 into the machine, so 8 was like this earlier. 8 was like this. 8, and this was 1 and 1. So what's the area when it's 8? If I put 8 into our
8.
machine, sorry?
8.
Yeah, it will spit out. So clearly you can see that a length of 6 is better than a length of 8, because a length of 6 gives you an area of 12. A length of 8 gives you an area of 8. Can you see you're trying to maximize A for the output? Can you see that, Chelsea?
Okay.
So basically, I want you to create a machine where you input an X, and then it will spit out an area, and you're trying to maximize the area. So suppose it's not of length 8 or 6, but it's of length, hang on. Suppose it's of length, hang on. Suppose it's of length X. Okay, Chelsea, what must height be? If that length is X, then what must the height be?
X plus 1.
X plus 1. So this must be X plus 1, right?
No. X
By the
minus.
wait there, Chelsea. By the way, for you to say X plus 1, it means this length is X. So X plus 1 would be that whole length plus an extra meter. So X plus 1 seems a bit silly. It's not X plus 1.
X over 2.
X over 2. So you're saying, hang on, you're saying for me to get the height, I should be looking at my length, X, and cut in half. That's what you're saying,
Well,
right?
I don't know what else to put it.
Well,
It's
okay.
random.
Well, wait, it's not random, because if you go back to earlier, when I gave you 6 earlier, you automatically knew it was 2 and 2 in order to get 10. Didn't you?
Yeah.
Oh, okay. It's not random. Look. All right. Earlier. Okay. Suppose I were to say, hang on, let me think. Suppose this has a length of 4. Then what must this length be? What must this length be?
3.
How did you know that? It's not random. Look, it has a length of 10.
Well, because you put X. I don't know what X is.
All right. Whatever X may be. Oh, okay. Okay. Yeah. Suppose this is X. What must this be, Chelsea?
I just said I don't know.
Okay. All right. Let's look at the original length of 10 meters. Okay. Let me clear this up. All right, Chelsea. If you decided to make this length here X, that means I'm going to cut this X up. Do you agree? Hang on. I'm going to cut up this X of length X. So this length will be used for the width, for that width there. Okay.
Okay.
So you see the remaining fencing. I'm going to cut in half, so that this half can be used for this, and the other half can be used for this. Do you agree?
Yeah.
So really,
I
this
don't know
length
what it's
here,
called.
sorry?
I don't know what it's called.
Okay, so what you do is this, Chelsea. You got a length of 10. So if you know you're going to use this much up for the width. Do you agree?
Okay.
What's the remaining piece here? What's that remaining piece?
I don't know
What's
what
that
it's
length?
called.
It's actually 10 minus x. That's the length. That length there is 10 minus x. If you think about it,
Okay.
earlier I said that this was 6. Can you see the remainder must be 4? Because you use 6 for this part. Can you see 10 minus 6 is 4,
10
right?
minus x over 2.
Yeah, so this thing here is actually 10 minus x over 2, right?
Mm-hmm.
And what's this length here? What's that length?
10 minus x over 2.
Yeah. Okay. 10 minus x over 2. Do you agree?
Mm-hmm.
So let's try and simulate this in DESI. So jump to Desmos. So the bottom left-hand corner, we're going to use as the origin, and then we're going to add our slider, bracket 0, comma a, close bracket. Josie, put in that point, bracket 0, comma a. Okay, so add our slider, and then limit our slider from 0 to 10, because the maximum length is 10. 0 to 10. Scroll, yeah, from 0 to 10. And then, oh, hang on, Chelsea. Our coordinates should be a, comma 0, not 0, comma a. Sorry.
Wait, what?
A, comma 0. It should be a, comma 0. A, comma 0. Yeah, and then slide it back and forth. So that's going to represent our width. Okay, we can move it from 0 to 10. Okay, and so we got to draw so that A there we can slide back and forth. Jump back to I drew, Chelsea. So this is our origin here, Chelsea. Hang on. This is our origin here, 0, 0. Can you see our origin right here, Chelsea?
Mm-hmm.
That's our origin. So when it's at A here, the height would be 10 minus A over 2. That's the height of our rectangle. Okay.
Okay.
Okay. So I'm going to try and simulate it in Desmos. So go back to Desmos. Go back to Desmos. Next input, add a table. Add a table. So go to the plus icon above the red dot, and then add table. Okay. So from the origin, so 0, comma 0. Okay, and the next one will be the height will be. Hang on, let me think. It would be 0, and then the next cell would be 10 minus a over 2. So you might have to use brackets. 10 minus a over 2. Yep. And so that's the height for a given a. And then the other point would be a across. So a across, and the height would be bracket 10 minus a close bracket over 2. Over 2. And then the last point would be a across, and it has a height of 0. and then click on the black icon for 2 seconds, and then 2 seconds, yeah, and then go to lines. So as you select your width, it will draw. Well, is coloring really that important? Okay, yeah. So I'll put it onto 8, Chelsea. Earlier I asked you if you select a width of 8, then you know you're going to have a height of 1. Go and put it on 8. Put A to 8. You see that? It has a height of 1.
Mm-hmm.
And if you put it on 6 earlier, then you know the height will be 2. Go on, slide it to 6. Slide it to 6, Chelsea. Yeah, so it has a height of 2. Go on, if you put it on 6, and then if you put it onto I don't know, what was it earlier? If you have a width of 4, it will have a height of 3. So basically, you got to slide it back and forth where it will give you the biggest area. Okay, Chelsea, do you understand the situation?
Okay.
So what value there will give you the biggest area, Chelsea? Oh, by the way, what's the domain for our situation, Chelsea? Chelsea, jump back to iDrew. Jump back to iDrew. So I'm using A, so A can be X if we want to. So our domain would be this, Chelsea. Domain dot domain.
X cannot be a negative number.
X cannot be. So you're saying domain X can be anything on the real number line, comma, and then you're saying X cannot be a negative number. So I'm going to write it like this: X must be bigger than 0. Is that what you're saying?
Yeah.
Can it be dead on 0?
Yes.
Well, if you have a width of 0, then you're not going to have an area. So your pens, your area is going to be 0.
No.
The chickens are not going to be very happy, are they? Chelsea, speaking to the microphone.
You
Can't
can't
hear you.
put 0.
Speaking to the
You
microphone.
can't put 0.
Yeah, so it has to be strictly bigger than 0. So that's your domain, is it?
Yes.
So why don't I make X to be 1000?
Oh, and X has to be less than 10.
Can it be dead on 10?
No.
Correct.
Yes.
So it must.
No.
Make up your mind. Which one?
No.
Well, if you have a length of 10, then you're not going to have a height. So if you're not going to have a height, you're not going to have an area.
I
So the
just said
domain.
no.
Okay, fair enough. Okay, so the domain is given by this. Okay. But the thing is, what you really want, Chelsea, is if I give you an A or an X, I don't care, A or X, you have to be able to tell me the area. So what's the area? Earlier, I said if you put in an 8, you told me the area would be 8. You could tell me the area. If we put in a 6, you said the area was 12. Again, you told me the area. If I put in an X, what would be the area? Chelsea, I want a formula for it. Area equals what in terms of X?
Area equals
So area equals
X plus 10 minus X over 2
X plus.
10 minus X
Hang
over
on.
2.
Let's start again. What's the area?
X plus 10 minus X
X plus 10 minus X
over 2.
over 2. So if this is 6, and the height there you know is going to be 2, so you're going to get 2 plus 6. That's not right. That doesn't give you the area. Else?
Right?
Oh, okay. Suppose X is 6. Okay. So this length here is 6. Do you agree?
Okay.
Then what's the height, Chelsea?
Wait, I wasn't done.
Sorry?
Wasn't done with the formula.
Oh, you're not done with the formula. Come on then. No. Well, hang on, Chelsea.
I don't know.
Let's start again here. Suppose the width is 6. What's the height?
2.
2. Okay. What's the area?
12.
Yeah, so what did you do? Did you get 2 plus 6, or did you get 2 plus 6 squared? Or what
2
did you do?
times 6.
Yeah, you simply get the height times the width. That's all you need to do. Get the height times the width. Get the height times the width. Well, the width is x or a, so we can change these if we want to, but the width is x and the height is this thing here. So what's the area? Can you see your formula is not correct, Chelsea? You're saying get the width plus the height squared. Can you see that, Chelsea? That's not right.
Okay.
So what should it be? What should it be? Chelsea?
I'm thinking.
Okay. Well, if that length there is 6 and the height is 2, how did you get 12? You simply got the height. Well, to get the area, you would get the width times the height. That would give you the area of the whole thing. Right, Chelsea?
Wait, what?
Um,
How do I make-
Speaking to the microphone, I can't hear you.
how do I make the formula? I don't know.
Well, okay, what's this length here, Chelsea? What is this length?
X.
Okay, what's the height?
10 minus x over 2.
So if you want an area, just get the base times the height. Chelsea, if you have a rectangle where this is 3 and sorry, this is 4, this is 3, what's the area? Scroll down a bit, Chelsea.
12.
What's the area? If this has a length of,
12.
yeah, suppose you have a 5 and a 2, what's the area? Chelsea?
10.
Yeah, what did you do? You got the base times the height. That will give you the area. It's always base times the height to get the rectangle. So all you have to do, Chelsea, is get the base, which is x, times the height. So the area is given by this x bracket x minus 10 minus x over 2. There. That will give you the area, wouldn't it?
Mm.
Do you get it?
Oh, yeah.
Yeah, it's always the base times the height to get the area. If you want a triangle, then cut it in half. But we don't. So what goes in here, Chelsea? What goes in this box? What goes in that blue box? Chelsea, what do you write in that blue box? Because in that blue box, I'm asking you the area as a function of x, meaning you've got a machine here, you put x into the machine, it should spit out an area. So what do I put in this box? What do I put in that box? Yeah. Okay. So let's use bracket. So it looks nicer. Okay, Chelsea,
Mm-hmm.
go and tidy this up. What is that? If you were to tidy this up, what does it look like? Because it's really this times this times this. So what does that look like, Chelsea?
What?
How would you tidy this up? Because
Mm.
I've given you one block times another block. So how would you tidy this up?
Um,
Speaking to the microphone, Chelsea.
Thinking.
It's like me giving you this, Chelsea. How would you tidy this up? A bracket B minus C. You would,
Supply it out.
yeah. So that would be AB minus AC, right? What happened to the 2? Oh, I see what you did. Okay, yeah. So we'll look like this. Okay, so basically for any given x or small a, this thing here would be your area, right, Charles?
Okay.
Charles? So if you punch this into Desi, go on, jump back to Desi. Next input, punch in 5a minus a squared over 2. So that would give you a number to represent your area, no matter where a is. Yeah. So now slide. Oh, sorry, not x. You used x. Should be a. Chelsea. Should be a squared. So no matter where a is, it will tell you the area. So slide a back and forth, and do you want the biggest number or the smallest number?
Biggest.
Yeah, because you're trying to maximize the area. So scan around until you get the biggest area. What's the biggest area? What value of a will give you the biggest area? So that has an area of 0. That's not good. The chickens are not going to happy. They're not going to be happy. So what seems to be the biggest area? So you reached up to 12 there. Only 8 now. What? You reached 12 earlier. Now it's getting smaller. So somewhere between there's a good length where we'll give you the biggest area. So where is it? Where is it, Chelsea?
Like 4.5, maybe.
About 4.5. Don't forget, it could be 4.93262. It could go on forever. We want it precisely. Okay, Chelsea.
Okay.
Okay, let's go back to iDrew. Chelsea, go back to iDrew. What does this graph look like? Because we want to draw a graph of area for given x. What does this graph look like? You know, if I were to give you, let's say, x squared plus 5x plus 7. You know, we did this in the past, Chelsea. I asked you to sketch this graph. Can you remember how to sketch that? When it's small, it wants to do this straight line. So an intercept of 7, a gradient of 5. So an intercept of 7, a gradient of 5. And then, yeah, and then it wants to do the, yeah. So that's what it looks like. But we got to draw this one here, Chelsea. What does this one look like? And don't forget, this is a negative quadratic, so it's got to be upside down. And when you have a coefficient of a half, it just makes the graph fatter like this, wider. Can you see that? Yay or nay, Chelsea?
Yay.
Okay, what's the intercept of this graph? Okay, looking at this, Chelsea, what's the intercept of our previous graph? Looking at this, 7, that's the intercept. But here, you don't have a constant. Can you see that? You don't have a constant like 3. You don't have a constant like 2. You have a constant of 0. Right? What's the intercept of this graph, Chelsea? Do you know the intercept?
0.
What? Yeah, 0. Because if you put 0 into here and then into here, it would jump to a height of 0. So you know it has an intercept of 0. And then it wants to do a gradient of 5, so like this, and then it has to do a negative quadratic. So sketch it. What does this graph look like? What does it look like, Charles? It has an intercept of 0, it has a gradient of 5, and then it has to do a negative quadratic. Why are you producing a positive quadratic? Yeah, let me just redraw it, because that's pretty ugly. It will look something like this. I don't know, something like this, basically. Okay, I'm just going to erase this 7. It has nothing to do with it. Okay, Chelsea?
Okay.
So as you slide A back and forth, this graph represents the area of our little pen thing, for our chicken, right?
Okay.
What bit are we after on this graph? What are we after? Or are we looking, what part are we interested in? What part of this graph are we,
The highest.
the highest point? Yeah, because we're trying to maximize the area. We want the highest area. Okay, how do we find the highest point?
You
Josh?
find dy by dx.
Yeah, but in this case, it's a and x, not y. Okay, so basically, I want you to find d capital A over dx. So what is it? We want to find out where the gradient will be zero, because at the highest point, the gradient will be zero. So find dy, well, dA by dx, where it will be zero, where the gradient will be zero. So differentiate it. What do you get, Chelsea? If you differentiate this, what do you get? How do you differentiate 5x? How do you differentiate 5x, Chelsea? Yeah.
5x is 5.
Sorry? Yeah. Oh, what? And then how do you differentiate this? What's that? Hey, Lynn? Oh no, you're thinking like 1 over x, where the variable is at the bottom. That thing there, the variable is at the top. So when you visualize that, it's got to be like 1 over 2 x squared. You should be visualizing it like this. You're thinking of like 1 over x. When you differentiate 1 over x, it would be natural log of x. Can you see? You're not looking at a scenario where x is at the bottom. This thing here is x is at the top. The variable is at the top. Can you see that, Chelsea? Chelsea?
Okay, so how do I do it? How would I do it?
How do you differentiate 3x squared? How do you differentiate 3x squared? Yeah, so remember the power comes down, which will be 6. The x stays the same. The power gets minus by 1. That's how you differentiate it. Right? Right, Charles?
Okay.
So here I've given you this number, half x squared. So how do you differentiate this? How do you differentiate it? Remember, the power comes down. The x stays the same. The power gets minus by 1. How do you differentiate it, Charles? Yeah, what happened to this half?
That's what I'm thinking.
Oh, okay. How do you differentiate a half x squared? Yeah, that half will combine with that 2 to give you a 1. Yeah. And then now what? Now what? So we are currently here at the moment. What now? I want to know what value of x will give us a gradient of 0. What do we do now, Chelsea? Are you thinking?
Yes. No, I don't know.
Well, you want to find out where the gradient is 0. You want to find the highest point. Right, Chelsea? You want to find this point here.
Yeah.
The point. Well, at the highest point, the gradient would be 0. So you put 0 into the dA by dx.
Wait, why
Put
is it
0
good
into,
as? Oh, yeah.
yeah, put 0 into there because you're searching for a place where the gradient would be 0. So basically, it boils down to you trying to solve this. So what now?
And then you
What
put
now?
0, and then you solve for x.
Okay, so what is that? How do you solve this?
-5.
Oh no.
Oh, hold on.
Yeah. So what does that mean on our diagram? Oh, so zoom to our diagram, Chelsea. Scroll to our diagram. What does this x equals 5 mean on our diagram?
That's the highest at a gradient of 0.
Yeah, basically it's right here, right? This value of x equals 5 right here, the gradient would be 0. Okay, that means the length of the length should be 5. That will give us the biggest area. So if you go back to DESI, jump back to DESI, and then slide it to 5, that should give us the biggest area. Yeah, the biggest area occurs when the width is 5. Can you see that?
Mm-hmm.
Okay, what would be the area when the width is 5? What would be the area when the width is 5?
5 times 2.1.
Yeah, but why not just look at that formula that you created earlier? 5a minus a squared over 2. It tells you right there.
So I put 5 into the A?
No, you don't need to, because currently you can slide a back and forth. Decimals will work it out for you. Currently, because a is on 5, it will work out the area when a is on 5, which is 12.5. It tells you right at the bottom. Do you get it?
Repeat that? What?
Oh, okay, slide a to 8. Slide a to 8. Earlier, we said that when it's at 8, the area would be 8 as well. Look, it tells you the area. Right at the bottom, the area is 8. Can you see it?
Yes.
Chelsea. All right, slide it to, what was it, 6 earlier. And we said the area was 12. There, that bottom formula there tells you the area is 12. If you put it dead on 6, put it dead on 6, because you're not dead on 6 yet. Yeah, the area is 12. So all you need to do when you put it, all right, put it back to 5. Earlier, when you we said that the biggest area occurs when x equals 5. So put it back on 5, Chelsea. Okay, earlier you were on 5, and then I asked you, what's the area when x is 5? So what's the area, Chelsea?
5 times 2.1, I said.
Yeah, but why bother doing that when you can just look at that number, 12.5? It tells you the area. You know, right, that number right at the bottom, 12.5, Chelsea.
Where?
Right at the bottom.
Where?
All right.
Oh, yeah.
Yeah, that thing there, that number there, 12.5, tells you the area. All right, put it back to 8, Chelsea. Put it back to 8. Slide it to 8. Can you see the bottom numbers jumping about? That tells you the area each step of the way. There, the area is 8. And then put it back to 6. Go slide it to 6. There, when it's 6, down on 6. Yeah, there, the area is 12. So put it back on 5, because that occurs when the area is biggest, when the width is 5. Go on, Chelsea. Put it back to 5. Oh, you can just punch in the number 5 and it will jump to it. Double click on it and then punch in the number 5. Yeah, there. Okay. When the width is 5, what's the area? And don't say 5 times.
12.5.
Yeah, you can just read that, because we punched in the formula for the area, so you can just look at the formula rather than telling me it's 5 times 2.5 or whatever, right? Right, Chelsea?
Yeah.
All right, jump back to iDrew. So going back to our original problem, Chelsea, go on, scroll up to our original diagram. Scroll up to our original diagram. So hang on, let me clear everything. So so this is your house here, and your dad has bought 10 meters of fencing. You want to maximize your area. Oh, zoom out slightly, Chelsea. Zoom out slightly. So this is the origin here. This is your house here, Chelsea. And your dad has bought 10 meters of fencing. How should he build it so that he will maximize his area? How should he build it? Draw an eye, Drew. How should he build it? Should he build it so that it has a length of 8, 1 up, or what?
Has a short, or
What?
has
So
a length of 5.
It has a length of 5, and this height?
4. Wait, let me think. 2.
And then this height?
2.
So what's the total length?
No.
Shake my head. What's the height?
2.1.
2.1. What's this height?
2.1.
So what's the total length? You've got a
12.5.
length of 9.2.
Oh.
Why bother wasting a tiny bit of fencing, Chelsea? Chelsea, what's the height? The height is not 2.1. What's the height? Oh, all right, think of it like this, Chelsea. See that length of 10 meters of fencing, right? Chelsea,
Yes.
if you use 5 for the top part, what's left? Chelsea, what's left?
5 left.
5 left. Why don't you cut it in half?
2.5.
Yeah, 2.5, isn't that?
Yeah.
So that's how your dad should build it to maximize the area. What would be the area?
12.5.
What? Yeah, is it 12?
12.5.
Was it 12.5? Jump back to I drew.
Yes, it was.
Okay, I'll take your word for it. 12.5. Are you sure?
Yes.
Was it 12.5?
Yes.
Okay, well, anyway, so that's how you do it. That's how you do it. Right at the beginning of the lesson, I asked you how to do it, and then you say, oh, how are you supposed to know? How are you supposed to know? Well, that's how you do it. Do you get it, Charles?
Yes, but I would need guidance.
Oh, what a wimp. Anyway, we call it a day here, okay, Chelsea?
Okay.
Thanks for the lesson, Uncle Chow. You're the greatest.
Thanks for
For
the
the-
lesson.
Uncle Chow, you're the greatest.
No.
All right, bye-bye, Chelsea.
Goodbye.
Bye-bye.